Welcome to our presentation of the Smart Office Defender. I'm Melisse, and with me presenting our project is Kathleen, Stephen, and Yuning. Our client, as well as our technical advisor, is Dr. Stephen Knudsen. Our Smart Office Defender is an open source project and is our way of deterring intruders from entering private spaces. We decided to do this by developing a web application that authorized visitor images can be uploaded to, and using our facial recognition algorithm, we compare those faces to those in the live video feed. If they do not have access, then they will be warned and shot with a Nerf gun that tracks the intruder's movements. Overall, we were able to surpass our walking skeleton and develop our project further. We were able to get the facial detection and recognition done earlier than expected, so that when it was trained in time to build a web application and also be able to integrate it with the hardware portions. The only issues we encountered were not completing some complementary functions due to the limited time frame. We were not able to create a passphrase algorithm that gives a visitor access to the room if the right passphrase is detected. There was also not enough time to ensure that the algorithm reads the images from the web app automatically, and thus it must be retrained manually. We will now show a demo of our prototype.
I think I'm cute. I know I'm sexy. I've got the look that drives to go wild. I've got the move that really move 'em. I said chill, up and down their spine. I'm just a sexy boy. I'm not.
And now let's take a closer look at all the hardware components. We've got the motor hat here attached to the Raspberry Pi itself, all hooked up to the camera right there. And if we go down a bit, we've got the control relay. We've got 8 of them here. Technically we only need 1, but the 8 was cheaper, so. And we have the horizontal motor, turns the gun horizontally, and the second motor that turns the gun vertically. Let me zoom out a bit, so it's alright. And we've got a third motor that triggers the mechanism to fire the gun itself, glued very cleanly of course. And the power connectors come up here into a single cable that plugs into the wall, and all of it is held together by a, I'll call it a decent piece of carpentry. Well, all that hardware certainly looks pretty cool. Now let's see it in action. So as you can hear in the background, the constant motors inside the Nerf gun itself accelerate the darts as they're pushed into the chamber. And as for the firing mechanism, well, it's very similar to a real gun, a double action revolver. Every pull of the trigger automatically rotates the cylinder and puts a new dart into the chamber. So the only mechanism that needs to be simulated here is the motor that you can see in the frame turning, replicating the effect of the trigger pulling mechanism. And now let's take a look at some of the scenarios under which this device will operate. First you'll see me, an unwelcome visitor, standing in front of the camera and being shot at. In that previous scenario I was able to duck out of the way quickly enough, but if the unwelcome visitor were to continue standing in front of the camera, then the Nerf gun would, well, continue shooting. And in this scenario, we'll see what happens when the user shifts to the side slightly, and we'll see the horizontal motor in action, turning the Nerf gun to continue aiming at the visitor. At the moment, the tracking of the device is not great. You'll see the Nerf gun turns very slowly, and it's very easy to avoid it. But this is something we would have continued working on if we were able to. And finally, we'll take a look at what happens when a recognized visitor stands in front of the turret. In this example, I've uploaded my face as a recognized visitor, and so as you can see, the turret does not react, and I will be able to step through just fine.
So here's the web application portion of the Smart Office Defender. This is a web app using Flask that runs directly on the Raspberry Pi unit in parallel with the main program. Because it is hosted on the Pi, the web app is available to any devices on the same network as the Pi. Therefore, it allows the user of the Defender to access this page from a phone, laptop, or computer. The web app is pretty bare in terms of visual appeal, since the functionality portion of the app was our main focus for this first prototype. Currently on screen, you can see the home page where the user can navigate to 2 websites through the links. one for viewing visitor records, and one for importing images of friendly visitors. So if we go into the visitor records, this shows all of the visitor records that are stored by the Smart Office Defender. So basically anybody that enters the office while the device is on. The data for the records are stored in a JSON file with the images stored separately, all within the Pi storage. So this table shows the date and time of each visit, the image of the visitor, and the actions taken by the device. These records that are showing right now are from our testing phases, where we didn't have a chance to get other people to try our device on. So we manually went into the code to set ourselves as both friendly and not friendly. So here you see the same person in all the records, but behind the scenes, they are considered as different people. The first and last records are classified as a friendly face, therefore there's no action taken by the device, so no action and no action. And the middle two records are considered as a unknown person, where one person left, therefore the gun was not triggered, and then one where the person did not leave, and then the Nerf gun was triggered and shot. So now if we go back to the home page and into the import page, here is a place for the user to upload images of potential visitors that they would like to classify as welcome, and therefore the device shouldn't shoot at them. Again, it is a relatively simple page where you can enter the visitor name and choose an image file of the visitor's face. So here, if I type in my own name and choose a image file, here a JPEG of myself, submit. So this process here basically just saves the image on the Pi within a directory based on the name given. So you can upload multiple images of the same person, and they'll store them together. And once the main program is reset, these new images will be trained into the system to allow these people to enter without being shot. Currently, there is no functionality to automatically train the system once the image is uploaded, but that is definitely something that we would like to implement in the future. Along with that, there are many other places where we want to improve this web app. One being the appearance. It's kind of pretty plain and ugly right now for the prototype. Another one being potentially adding a live camera feed to the web app itself, so the user can monitor what's going on in their office through the device's camera. And then lastly, to implement a login page for security purposes. For example, we don't want someone to go into the site and just import a selfie of themselves and be able to get into the office. So there's definitely a lot of room for improvement for this portion itself, but it does do what we wanted it to do for the prototype, so that's good.
Okay, so now I'm gonna show you what the camera sees when a person faces the camera. First and foremost, it will be able to detect the face. Upon detecting a face, it would evaluate if that person is a desired visitor or not. So in this case, we can see it recognizing a face and then a name identifying that person. So in this case, it's Kath, which is my name. That means this is a desired visitor and it will not trigger the gun. Then you can also see that if I move to any position in the frame, it would still recognize it as myself. Okay, so for our next scenario, it will be for undesired visitors, and you can still see that it recognizes the face, but this time, instead of having a specific name, it's identifying it as unknown. For our future work, we could add a passphrase function. This will allow the unknown visitor to say a safe word, so even though they were identified as unwelcome, if they say the safe word, then the gun will not be triggered and they would still be allowed to come in the room. Okay, next, since we're living in a pandemic, I'm wearing a mask and sunglasses. Then you can see that it's not identifying any face and no action is being made from the system. If I remove the sunglasses and retains the mask, you can see how it is now recognizing a face, but it is identifying it as an unknown. If I try to remove the mask, it should then identify it as myself.
And so this concludes our presentation for the Smart Office Defender. We will be happy to answer any questions you may have for us.